This is chapter 2, which is part of inorganic chemistry, that is chemistry of outer transition elements, and we are discussing the general properties of the d block elements, transition elements, and from that particular topic, today we will study the catalytic activity of the transition elements. Before I start with this topic, I'd first like to ask you about the catalyst. So what do you think a catalyst is? A catalyst is a substance that increases or decreases the rate of reaction, which means if the reaction is too fast, so it will slow down the reaction and normalize it, and if the reaction is super slow, then it will speed it up. So either it increases the rate of reaction or decreases the rate of reaction, but itself is never consumed in the reaction. Now for the catalytic activity, transition elements serve as the catalyst. If you remember that in chapter number 1, for the contact process, that is preparation of sulfuric acid, in step 2, that is the conversion of sulfur dioxide into sulfur trioxide, a catalyst was used, and that catalyst was vanadium pentaoxide. Vanadium is a transition element, which means that transition element or its compound serve as the catalyst. For example, we have different transition elements that serve as catalyst. Nickel, which is used as a catalyst in the addition reaction of alkene. Iron, used in the synthesis of ammonia as the catalyst, and vanadium pentaoxide, which is used for the manufacturing of sulfuric acid by the contact process. Nickel, iron and vanadium, these are the transition elements. In the first two examples, nickel and iron transition elements are used directly, but in the third example, the compound of the transition element is used. It means either you can use it in elemental form, like in the original state, or in its compound form. In both conditions, it serves as the catalyst, either increase or decrease the rate of reaction depending upon the requirement of the reaction. What causes this catalytic behavior of the transition elements? So there are two factors that are involved for the catalytic behavior of the transition elements or that make them function as the catalyst. The first one is that they have variable oxidation state. And what was the cause of this variable oxidation state? Because of small energy difference between the 3d and 4s orbitals. And this variable oxidation state can easily make them withdraw or lend the electrons from the reagent, which forms the unstable intermediate, which then ultimately changes into the final product. The second factor that is involved for the catalytic behavior of the transition element is that the surface of the transition elements offer active sites. And by active sites, it means it offers certain places on the surface or the top layer of the transition element where the acting reactant molecule gets absorbed and then they perform the reaction. It means it performs the site of reaction. It provides site of reaction for the reaction completion. The first factor is variable oxidation state, so they can easily gain or lend electron depending on the reaction condition. The second factor that we have that causes the catalytic activity of the transition element is that they have active sites. They provide site of reaction to the reactant molecule so that they can get absorbed and then perform the reaction. Here you can see that in the second term the word used is adsorb, not absorb. Adsorb is a surface level phenomena. It occurs on the surface only. The transition elements are not itself taking part. They are just providing the surface for the reaction to the reactant. That is why you must write adsorb, surface level phenomena. The keywords here are variable oxidation state and the active sites provided by the transition elements. How you get this question in your board examination? I have prepared the self-assessment question as well in the same format. Many transition elements and their compounds serve as catalysts. So what will be the reason? How will you explain it? You have to mention both the factors. The first factor is that they have variable oxidation state, so they can easily gain or lend electron, donate electron, provide electron, and forms the unstable intermediate which ultimately gives the product. Second point that they have is that they provide the site of reaction because they have active sites on its surface where the reactant molecule gets absorbed and the product is formed. So when you get this question in your board examination, you must write the complete answer. From these two factors, if you are mentioning only one factor, that is an incomplete answer. To attain full marks, you must mention the complete answer, which means both the factors, that is variable oxidation state and active sites on the surface must be mentioned to attain full marks in this question. You get this in your 4 marks inorganic short question answers where you are asked to describe the scientific reasoning. You get 4 questions, and in that 4 question you get one of these questions, which means one question carry 1 mark, which makes it a total of 4 questions. So from the property that we have discussed today, you will be getting this in your short question answers in the scientific reasoning for 1 mark. Also, you might get this in your multiple choice question in which they ask you about that iron is used as a catalyst in the synthesis of ammonia. So they may ask that for the synthesis of ammonia, which catalyst is used. You can simply tick on iron and get full marks. They may ask you to write the example of the transition element that I use as the catalyst, so you can write down the examples. So make sure that when you attempt this question in your board examination, you are writing complete answer along with the keywords that I have shared in this video. If you want, you can make notes from this as well and then simply rephrase your answers. It's completely up to your creativity. This is all for today. Thank you.